So what is OpenMP? It's an application programmer interface for shared memory model programming. It consists of compiler directives. We saw compiler directives. Which one did we see? Hash pragma OMP parallel, when we wanted to define a parallel region, right? These are directives for the compiler. These are picked up by the compiler when you compile the code and replaced with some other code. Okay, the compiler figures out what to put over there. Then there are runtime library routines. These are functions which can be invoked within your code. So there's a library that is linked along with your code, right? The OpenMP library, and it provides support for all these functions. What are the examples? We saw OMP get num threads, OMP get thread num, and so on, right? So these are functions. So these are also a part of OpenMP. And then there are environment variables. So we saw an example of an environment variable, OMP num threads, right? That sets the number of threads that you want to execute in the parallel region. All right. So what are the advantages of using OpenMP? Well, standardization and portability is the most important one. So as you carry your code from one platform to another platform, you don't have to change your code again, right? When you move from a GCC compiler to, let's say, an AIX compiler, you don't have to change your code again. OpenMP is a standard which, if a compiler says it supports the entire set, right? There are different versions of OpenMP. So you just have to be aware of which version is being supported and what are the features being provided by that version. And no matter which compiler you use which supports that version of OpenMP, your code will compile and run properly. Okay, so that is the biggest advantage. And of course, ease of use. So OpenMP is very, very simple in the sense that you can start off with the code that you had, the sequential code that you had, and you can just compile it with OpenMP and run. You just have to hash include omp.h. It will run. Just that it will run sequentially. And now if you want to parallelize, figure out which is the most time consuming part. Go to that part and just figure out how to parallelize that part. You don't have to touch the remaining code. That's a huge advantage. Okay, that makes parallelizing codes very, very simple. You can start with a sequential code. If you go to something like MPI, message passing interface, you have to rewrite the entire code before you can run it in parallel. That's a challenge with message passing programs. So that's the advantage of shared memory programming, and OpenMP, of course, that ease of use. You can incrementally parallelize your code. Start with a sequential code and then incrementally pick up one part, then another part, and so on, and parallelize it. OpenMP has been around since 1997. That was version 1. The latest one is version 4. It's a thread-based model. So there are threads which share the same address space, right? So everything is shared by the threads except for their own stacks, right? And the thread local space. So all the global variables, the code, everything is shared, right? Finally, OpenMP is based on the fork join model. So what is the fork join model? When you encounter the hash pragma OMP parallel region, right? When you encounter this compiler directive, at that time what happens is the compiler replaces this with a code that actually creates threads, right? So up to this point, up to the OMP parallel point, code is executing sequentially, right? There's a single thread that is executing. So let's say OMP num threads is set to 4, right? So what will it do? It will actually, at this point of time, it will launch 3 threads. Okay, it will launch 3 new threads, and one of the threads is going to be the thread which was already executing, right? So this thread which was already executing, this continues on as one thread, and 3 additional threads get launched at this point in time. And then the compiler sets them up so that they execute this code which is there in the parallel region, right? So all of them execute this parallel region. And when you encounter this parenthesis close, when the parallel region ends, at that point of time, a join operation is performed. So this is called forking, right? And at the end, a join operation is performed where essentially the master thread, so this was the master thread, remember? It will, at this point of time, wait for all the other threads to complete. Okay? So all the other threads, when they complete, they will come and join over here. And when all the other threads have completed, they have joined back. At that time, it will proceed ahead again with the remaining code. Okay? And now if it encounters another hash pragma OMP parallel directive, another parallel region, it will again do the same thing over again. right? Again, it will launch 3 additional threads, they will execute, and they will join back again. So that's called the fork join model.